Hello everyone and welcome to the chapter number 31 of Blender Master Course Geometry Nodes Creating Buildings. In this chapter we'll be exploring all these topics in complete detail and we'll also be creating the simple scene of these buildings with the help of all these topics. And yes, if you are new to this course, then do check out the previous 31 chapters from the link of the playlist in the pinned comment. So to begin with, the first topic for today's chapter is Extrude Mesh Node. And to understand it, we first have to open the Geometry Nodes workspace. So click here to open the workspace and click on the new button. Now to add the extrude mesh node, press Shift plus A, go to mesh, and in the operations you will find the extrude mesh. So I'll select this and let's place it here. And to connect it to the rest of the node system, if I left click and drop it here, then it will get connected and we notice some changes here. As the name suggests, the extrude mesh node basically extrudes up the faces of our cube object. Now here in the extrude mesh, you have some options. The first one is the mode of extrusion. By default it is set to faces, and as a result the faces of this cube are being extruded individually. But here we have some other options as well. So if I select the vertices, it will basically extrude the vertices of this cube object. The next option available is the edges, and just like the other two, this one will extrude the edges of the cube. But right now I will change the mode back to faces, and here you have the offset value, which basically defines the offset or the amount of extrusion that is applied to your cube. For example, if I increase it, then the extrusion will increase, and if I reduce it to somewhere near minus 0.2 or minus 0.3, then the faces will get extruded inwards. And here in the extrude mesh node, you can also see that you have these two options of selection and offset, but we'll study about them later on because it will require the use of some other nodes that we have not yet covered in this course. So for now, you need to focus on the mode of extrusion and the offset value here. Now there's also one more option available here, which is the individual, and it is turned on by default. It basically means that the extrusion will be applied to the individual faces. To understand it better, if I turn it off, then it would mean that the extrusion is not applied to individual faces but to the object as a whole. So if I increase the offset from here, you will notice that the object is getting extruded as a whole and not its individual faces. So this individual option is basically used to set whether you want the extrusion to be applied individually or as a whole on the object. And you can even apply this extrude mesh to any other type of mesh such as a UV sphere. So suppose you want to apply this extrude mesh to a UV sphere and add it in our scene. For this, in the Geometry Nodes editor, we'll first add the UV sphere node. So press Shift plus A, and since the UV sphere is a type of mesh primitive, so I'll go to mesh, and here in the primitives we have the option of UV sphere. So I'll select this and let's place it here. Now to apply the extrusion to it, I'll take this extrude mesh which is right now applied to the cube, and to create a duplicate of it, press Shift plus D and let's place it here. Now I'll take this mesh socket of the UV sphere and connect it to the mesh of the extrude mesh. And now if I take this output socket of the extrude mesh and connect it to the group output, here we have the UV sphere with the extrusion effect applied to it. And suppose you want to see both the cube and the UV sphere in the same scene. And to do this, we'll be using a node which we explored in the previous chapter. And this is the Join Geometry node. To add it, press Shift plus A, go to Geometry, and here you have the option of Join Geometry. So I'll select this and let's place it here. Now I'll take this mesh socket which is carrying the information about the extruded cube and connect it to Join Geometry. And also I'll take the mesh socket of the extruded mesh which is carrying information about this extruded UV sphere. So I'll select this and connect it to the Join Geometry. We'll break the node connection in between the mesh socket here and the group output. So hold down the control button, right click and drag like this. Now I'll take this geometry socket and connect it to the output. It appears like this because both the cube and the UV sphere are placed at the same position, which is the origin of the 3D world. And suppose I want to shift this UV sphere in the x-axis, and for this we'll be using another node from the last chapter, which is the transform node. To add it, press Shift plus A, go to Geometry, and in the operations you will find the transform geometry. So I'll select this and let's place it here in between the extrude mesh of the UV sphere and the Join Geometry. And to move the UV sphere in the x-axis, I will go to the translation and let's change the position in the x-axis. And now here we have the cube and the UV sphere properly placed in the scene, and both of them are showing this extrusion effect applied to them. And now let's revise whatever we did in this Geometry node editor. First we have this group input which is carrying the information about this cube in the scene. Then we use this extrude mesh to apply extrusion to all the faces of this cube individually. Then to add the UV sphere, we added this UV sphere node and connected it to the extrude mesh because we wanted to apply the extrusion effect on its faces individually. Then we had to add this transform geometry because we needed to move this UV sphere in the x-axis. And in the end we connected both of them to join geometry in order to see both the cube and the UV sphere in our 3D viewport, and at last we connected it to the output to see the final output here. Now moving ahead, the next thing that we are going to discover, instance on points node. To see how it works, I will add a plane without deleting all these. To do this, press Shift plus A, go to mesh, then in the primitives we have this option of grid. So I'll select this and place it here. We studied in the last chapter that we have to use this grid node to add a plane in our scene. To see the output here, I will break the connection between the join geometry and the output. So hold down the control button, right click and drag like this. Let's take this group output and place it here. Now to connect them together, take this mesh socket and connect it here, and here we have the plane in our scene. Here you can see that in the grid we have some settings like the size and the vertices. So if I increase the size in the x-axis, then it will get scaled up like this. Similarly in the y-axis, and here you have two more options, which are the vertices in the x and y axis. And to understand about them, we first need to go to the wireframe mode. For this you can click on this icon, or else there's a shortcut which is to hold down Z and take your cursor to the wireframe, and this is the wireframe display of the plane object. If I move it slightly in the y-axis by pressing G and Y and placing it here, and also in the x-axis by pressing G and X and placing it here, then now you can see here that in the x-axis it is having 3 points. One of them is here where it touches the edge, the second one is at the middle, and the third one is again here where it touches the other edge. And the number of vertices in the x-axis is controlled from this option in the grid. Here it is set to 3, but suppose if I increase it to a number like 5, then now we are having 5 points in the x-axis. One is here touching the edge, the second one is this, the third one is in the middle, the fourth one is this one, and the fifth is this last one, which is again touching this edge. Similarly, in the y-axis, the number of vertices is set to 3, and as a result, as we move along the y-axis, we have 3 points. First one is this, which is touching the edge, the second one is in the middle, and the third one is here at the end. You can change the value of vertices in the y-axis from here. So if I change this one also to 5, then now it looks like this. In simple words, you can understand it in this way, that this vertices option in the x and y axis is basically similar to the subdivision that we used to apply to our object. It helps to increase the number of vertices of our plane. And now coming back to our topic of understanding the instance on point node, we'll first add it here. So press Shift plus A, go to instances, and here you have the option of instance on points. So I'll select this and place it here in between the grid and the output, and suddenly our plane object disappears, and that's because we have to add some instance here, which in simple words means any object. For example, if I add a cube by pressing Shift plus A, going to mesh, and in the primitives, here I have the option of cube. So I'll select this and place it here. Now I need to connect this cube to the instance. So I'll take this mesh socket and connect it to instance, and we see some changes here. To view it properly, we'll go to the solid mode again, and here we first need to reduce the size of these cubes. So I'll select the sizes in all the 3 axes by left clicking and dragging like this, and I'll type 0.1 meters and press enter to confirm. And let's try to understand what happened here. Basically what this instance on points does is that it places the instances, meaning the cubes in this case, on the points or the vertices of our plane object. If you remember, we changed the number of vertices in the x and the y axis to 5 here, and as a result we are having 5 cubes placed in the x axis and also in the y axis. In simple words, as its name suggests, it places the instance or the mesh which is connected to the instance here on the points of a particular object which is connected to the points here. You can even control the number of these cubes from the vertices option in the grid node. For example, if in the x-axis I reduce the number to 3, then here we have 3 in the x-axis and 5 in the y-axis. Now you can also try to do some changes here. For example, you can apply the extrusion to all these cubes by going to the geometry nodes editor, and to add the extrusion, press Shift plus A, go to mesh, and here in the operations we have the extrude mesh. Let's place it in between the cube and the instance on points, and it appears like this because the offset value is too high. So let's reduce it to a lower number like 0.1 or maybe 0.01, and now it looks perfect. Also, I think that we should change the number of these cubes to 4 in both the x and y axis. So go to the grid node, select the vertices in the x and y axis, type 4 and press enter. Now we have 4 cubes in the x axis as well as in the y axis, and you can even try to scale them up from the size option here or from the scale option in the instance on points. So you can choose any of the two, both will work in the same way, and I think that we should scale them up to a slightly higher value in all the 3 axes. So let's change the scaling to 0.2 meters, or maybe let's reduce them down to a slightly lower number like 0.16 meters, and now it looks perfect. And yes, we'll be using these cubes to make the scene of the buildings. Now to convert these cubes into building, we have to make them taller, and for this we'll be using another node, which is the combine XYZ node. But before adding it, let's first zoom out, and we'll be deleting this entire node system because it is not required anymore. So I'll select all of this except this group input because it will be required for making these buildings. So to deselect it, simply hold down the control button, left click, and drag your cursor over the group input like this. Now it is deselected, and to delete, press X, and now they are deleted. Now we'll take this group input and place it here, and now moving back to changing the height of these buildings, we'll be adding the combine XYZ node. So press Shift plus A, go to utilities, and here in the vector you will find the combine XYZ. So I'll select this and place it over here. Since we need to manipulate the size of these cubes, so I'll take this vector socket and connect it to the size, and we can't see anything here because the size of these cubes is now being controlled by these values in the combine XYZ, and because they're set to 0, as a result we can't see anything here. To scale them up, I will select all the 3 axes and type 0.16 because that was the size that we previously entered as the size of these cubes. Now you might be thinking that what exactly is the use of adding this combine XYZ when you could have simply used the options in the size here to change the height of your building, and you will get to know this answer in a little while. But before that, we need to first understand about this group input node. You must have noticed here that in the group input node you have this empty socket here, and suppose I take the socket of the Z axis and connect it to this empty socket, then it basically creates a new socket with the name Z. And also if you go to the modify properties in this geometry node modifier, you can directly control the scaling in the Z axis from here. So basically whatever you connect to an empty socket will be created as a new socket in the group input node, and then you can control that specific value from the modify properties here. And this was the reason why we added this combine XYZ instead of using the size option in the cube. By doing this, we can now simply change the height of these buildings just by going to the modify properties and changing the Z axis. And now moving ahead, there are some more settings that you can do with this newly created socket in the group input node. For this, we first have to open the toolbar here by pressing the N key, and here you can see that we have a list of 3 items here that are present in group input and the group output. The first one is the geometry node, the second geometry node, and here on the third number we have this Z socket that we ourselves created. You can even change the name of this socket by double clicking here, and suppose I change the name to height and press enter to confirm, and here in the geometry node editor the name of this socket is changed. You can even control the type of value that can be added as an input in the height value here. By default it is set to float, meaning that you can add decimal values to the height here. But suppose I change it to integer, then in this case I can only add the integer values like -1, 0, +1, +2, and not the decimal values to it. But in this case I'll be changing the type back to float. Let's go to the height again and let's increase it to 0.16 meters for now. So this is how the group input node and the combine XYZ node works. Now moving ahead, in order to change the height of these buildings, we have to change the height value from here. But if I increase it, you will notice that the height changes both in the upward and the downward direction. But if we want to increase the height only in the upward direction and not in the downward, then for this we have to use another node, which is the math node. And the math node is probably that one node which has the maximum number of options in it. To add it here, press Shift plus A, go to utilities, and here in the math we'll select this math node. Let's place it here, and now if I click on this drop down, you can see here that we have a lot of options in the math node. By default the add function is selected here, but we'll be learning all these options as we move further in this course while learning the geometry nodes. Now as the name suggests, this add option in the math node basically adds 2 values together. Here we have the option to add 2 values, and by default both of them are set to 0.5. As a result, it would add these values and return the output, which is 1, from this value socket. In fact, you can even connect these sockets against these values if you want to influence or change these values. And now to get a better view of the buildings, we'll go to the front or the side view by pressing 1 or 3 on the numpad. And now to increase the height of the buildings, if I go to the geometry node modifier and increase the height from here, we see that the height increases in upward as well as downward direction. Basically, in other words, we want that as we increase the height, all these cubes should move upwards in the Z axis so that they start from their origin point here. And whenever we have to change the position of our cubes in any direction, then we have to use the transform node. So we'll add it here by pressing Shift plus A. Let's go to geometry, and in the operations, here we have the transform geometry. So I'll select this and let's place it after after the cube node. And now if I go to the geometry nodes modifier and increase the height, then now I can move them upwards to their origin point with the help of translation in the z-axis. So if I slightly increase it by holding the shift button and increasing it by dragging like this, then they will move upwards and will begin up to their origin points perfectly. But whenever I will change the height from here, they will again get scaled up in the downward direction, and again I have to go to the z translation and change the value from here. And to solve this problem, we'll be using this math node. So let's first undo everything by pressing Ctrl plus Z 3 to 4 times. Now I'll take this math node and place it over here, and since I need to make the changes only in the Z axis, so I'll be using the combine XYZ node. Here we have already added it, so I'll select this, press Shift plus D to create a duplicate and place it here. Now take this value socket of the math node and connect it to the Z axis, then take this vector socket and connect it to the translation. Now to see the cubes here, we have to zoom out, and to bring them down, we'll be using this math node. Here this math node is controlling the translation in the Z axis with the help of these values. Right now these values are set to 0.5 each, and as a result, when they will get added, the output will be 1. Therefore, the position of these cubes will be 1 meters upwards in the Z axis. Also, you can control the position in the X and Y axis from here, which is set to 0.16 because we created a duplicate from here which was controlling the size, and therefore we are having these values here. So I'll select both of them and reduce it to 0. But even after doing all this, our problem is still not solved, because if I go to the height option here and increase it, we again have the same issue of the cube scaling up in both upwards and downwards direction. And this is because in the math node here, the two of these values are controlling the position of these cubes. But instead of these values, it should actually be the height which would control their position in the Z axis. To understand this properly, I will take this height socket of the group input and connect it to one of this value socket. And now what it does is that it will add the value of height, which is 0.6 right now, to the second value, which is 0.5, and assign that particular value to the translation in the Z axis. So if I go to the height option and increase it, then now we notice that this height option is controlling two things here. One is the scaling of these cubes, and the second thing is the movement in the Z axis. For example, if I increase the height to a very high value, then the cubes will move up in the Z axis, and if I reduce it, then their position in the Z axis will also reduce. Even though the movement in the downward direction is now reduced to some extent, but still it's not completely fixed, and that is because we are using the add option in the math node. Because whatever value I will assign to the height, this add option will increase it by 0.5 meters, and as a result, these cubes will go upwards in the Z axis. To fix this, we have to change the option from add to divide. And now if I increase the height from here and try to adjust the second value here to that particular point where it touches the X axis, then our problem will be fixed. And here at a value of somewhere around 1.8 and 1.9 with the height set to 0.82, it appears to be perfect. And now if I increase the height from here, we see that the buildings are only getting scaled up and down, and their position is not getting affected. And let's also understand how this divide option in the math node is working. Basically, the first value is set to the value of height here, which is 0.82, and the second value is 1.89. As a result, it will generate the output, which is 0.82 divided by 1.89, which is equal to 0.433 meters to the translation or the position in the Z axis. And as a result, the cubes appear like this. So you can basically use this math node with the divide option and connect it to the translation in the Z axis, and in this way you can change the height from here without facing the problem of these buildings or the cubes moving downwards in the Z axis. Now one thing to notice here is that the height of all these buildings is exactly the same, but to give it a realistic look and to have random heights for each of the buildings, we'll be using another node, which is the random value node. To add it here, press Shift plus A, go to utilities, and here you have the random value. So I'll select this and place it here. And now since we need to change the height or basically the size of these buildings, we have to connect this random value to the scaling here with the help of a combine XYZ node. So for this, I will press Shift plus A, go to utilities, and in the vector you will find the combine XYZ node. So I'll select this and place it here. Now the height of the buildings is controlled from the scaling in the Z axis. As a result, I'll take the value socket of the random value and connect it to the Z axis, then take this vector, and to connect connect this vector, we have two options here. One of them is the scale of this transform geometry node which is connected to this cube, and the other one is the scale option in the instance on points. And if I take the vector socket and connect it to the first scaling option, then we see that everything disappears and this connection line is turned to red color, which indicates some error. So I will press Ctrl plus Z, and let's try the same with the scaling in the instance on points, and this time also we see no output here, everything is disappeared, but this time this node connection is not red colored, which means that at least there is no error in this case. And in fact, connecting this vector socket to the scale option of the instance on points was the correct choice, because if I go to the combine XYZ and change these values in the X and Y to 1, then these buildings will reappear, and this time we are having some random heights applied to each of these buildings. Now let's also understand how this random value basically worked. We connected the random value node to the Z axis of the scaling through this combine XYZ node, and here you can see that it has two values. One is the minimum and the other one is the maximum. The minimum value is set to 0 and the maximum is set to 1, meaning that it will generate an output between 0 and 1 and assign it to the Z axis, and that particular value will be a decimal or float value, because here in the type of data we have the float selected. You also have other options like integer, vector, boolean, but in this case we required only the float, and so it assigned random heights between 0 and 1 to all these cubes. Now you might be having one more doubt in your mind, which is that why did we receive error when we connected the vector to the transform geometry but not in case of instance on points? And the reason is very simple. See, the transform geometry was carrying the information about this cube as a whole, whereas the instance on points was carrying information about all these instances which are the cubes. And since we needed a random height for each of the cube or the instance, we had to connect the vector to the scaling to the instance on points. Now here in the random value, you have another option which is seed, and by changing this you will basically generate another output with different random values assigned to the height of each of these buildings. So basically you can generate different outputs with the help of this seed value. Right now I will change it back to 0, and now let's move to the next topic, which is understanding the index node. And we'll be understanding this index node by first creating a simple cube here. So for this, let's move upwards in this geometry nodes editor, and for those of you who don't know, you can move around the nodes editor simply by holding the middle mouse button and dragging your mouse like this. So let's go over here, and to add a cube, press Shift plus A, go to mesh, and in the primitives here we have the cube. So I'll select this and place it here. Let's also add the index node. So press Shift plus A, go to geometry, and in the read you will find the index node. Let's place it here. Now to view the cube object here, simply hold down the Ctrl plus Shift and left click on the cube, and here we see our object. And also this shortcut will work only if the node wrangler add-on is turned on. Now to understand the working of this index node, we should first extrude the faces of this cube, and for this I will add the extrude mesh node. So press Shift plus A, go to mesh, and in the operations we have the extrude mesh. So I'll select this and place it in between the cube and the viewer node. Now here you can see that all the faces of our cube are now extruded, but suppose you want that only a specific face or some particular edge or vertex should have been extruded instead of all of these, and for this we use the index node. Now if I remove the extrude mesh from the connection in between the cube and the viewer by holding the Alt button and left clicking to remove it, and if I select the cube, then here in the spreadsheet you can see that with the vertex option selected, you have some numbers written over here. These numbers start from 0 and go on till 7. We learned in the previous chapter that these numbers are the index values of each of the vertices of this cube. See, every vertex, edge and face has a particular index value which you can use to manipulate the way it looks. Similarly, if I go to the face option here, then you can see that the index value of face is also starting from 0 and goes on till 5, meaning that there are 6 faces in this cube. Now suppose you want that this extrude mesh should be applied to only one of the faces and not all of them. To do this, I will first select this extrude mesh and place it here, and now we have to connect this index socket to the selection socket of the extrude mesh. This selection socket allows you to select which particular vertex or face or edge you want to be extruded, but to tell this selection socket that exactly which face at what index number should be extruded, we have to use another node which is compare node. So press Shift plus A, go to utilities, then in the math section you will find the compare node. So I'll select this and place it here. Now click here and change the operation to equal. We'll understand about this in a couple of minutes. I'll take this index socket and connect it to the socket A, then take this result socket and connect it to the selection. And now let's understand what exactly happened here. Previously, the extrude mesh was working on all the faces of the cube, but now with the help of this selection socket, we give input to this extrude mesh that we want a particular face of some specific index value to be extruded, and to calculate that index value, we use this compare or the equal node. And here we have two options. One of them is A and the other one is B. And as the name suggests, it basically makes the value of A equal to B, meaning that since A is connected to index, therefore the index value will be equal to the value of B, which is 0. So it will give the output or the result to this selection socket that this extrude mesh has to work on that face whose index value is 0. And suppose I change the value of B to some other number like 1. Then here you can see that another face is extruded now. Previously the extrusion was working on the bottom face, and as a result it looked like this, and when I changed the index value to 1, the extrusion took place on the front face. Similarly, you can even try other values like 2, 3, 4, 5 and it will create an extrusion effect on that particular face. And this is how the index and the compare node works. And now returning back to the buildings that we were creating, let's select all of this and press X to delete. And now let's give some material or some colors to our buildings. For this, first let's go to the render view by clicking on this icon. Let's also change the render engine by going to the render properties and changing it from EV to cycles. To get a proper lighting, click on this drop down arrow and turn off the scene world, and here we go. Now before creating the material, let's first add the set material node. So press Shift plus A, go to material and select the set material. Let's place it here. Now to create a material, let's change the spreadsheet window to the shader editor. So click on this icon and select the shader editor. Now we basically need to create a texture which will make it look like there are actually some windows on these buildings. To do this, we'll be using the Voronoi texture. So press Shift plus A in the shader editor, go to texture and select the Voronoi texture. Let's place it here, and to get the input and the mapping nodes, simply press Ctrl plus T, and here we have the input texture coordinate and the mapping node added. Here take this object socket and connect it to the vector, and to view the texture, simply hold down Ctrl plus Shift and left click on it. And we are not able to see the texture here because we have not assigned this material in the set material node. So I'll click here and choose this material, and this is how the texture looks like right now. Now here we are having some random spot-like texture on our buildings, but we really don't want that. To change the way it looks, click on this option where Euclidean is selected and change it to the other types. With the second option selected, which is the Manhattan, the texture looks like this, and this is also not perfect. So we'll go for the third option, and let's also try to change some settings here. For example, the randomness, and if I reduce the randomness, it's giving a slight texture which somewhat looks like the windows of a building. And to make it look perfect, let's reduce the randomness even more. So I'll change it to 0. Let's change the scale value. So if I increase it, we see some slight texture which resembles the structure of windows on buildings. To make it look even more better, let's further scale up the value to something like 10, and now it looks like this. Now you might be thinking that exactly how do you know that you have to use the Voronoi texture and try to change these settings in it to achieve a specific result? And the answer to this is that it basically comes with practice. You have to keep in your mind how each texture would look like on your object's material. For example, the noise texture would add some noise to your material, the Voronoi texture would add some spots to your material and make it look like this. Similarly, the brick texture and all the other textures also work in some specific manner. So my suggestion to you would be that you should try to practice by adding different types of textures, changing the values here, trying different options, and try to do this with all the textures that we have studied in this course so far. And if you want to add some more windows here, then you can use the scale value. Right now it is set to 10, but if I increase it to something like 12, then it looks like this. You can even use the scale options here to change the size and the number of these windows in the texture. So suppose I go to the scaling in y-axis and let's increase it to something like 1.5, and now it looks like this. Now to give some color to these windows and the building, we'll be using the color ramp. So press Shift plus A, go to converter and select the color ramp. Place it in between the texture and the output, and to change the colors and the intensity, we have to move these pointers and change the colors from here. So first I'll take the second pointer and move it like this. Similarly the first pointer, and let's move it like this. Now here one thing to notice is that this principal BSTF is not connected anywhere in this node connection, and there is a reason for this. Basically we will need two different principal BSTF added here, and that's because one of of them will be for the windows and the other one will be for the rest of the building. So to create a duplicate of this, press Shift plus D and place it here, and to connect both of them, we'll be using the mix shader, and to add it, press Shift plus A, go to shader and select the mix shader, place it here. Now let's take the output of one of the principal BSDF and connect it to the first shader. Similarly, let's take the other one and connect it to the second shader, and then take this color socket of the color ramp and connect it to the factor. And here we can no longer see the texture of the buildings in the 3D scene, and this is because previously the color was being controlled from this color ramp, but now since we have connected the shaders to this principal BSDF and both of them are having the white base color, as a result we can't see the texture here. To see the texture right here, I'll take the base color of one of the principal BSDF and let's change it to black color, and the texture is visible here. Now you can do one more change in order to make these buildings look very realistic, which is to go to the color ramp here and change the interpolation to constant, and now you can see that you have these windows on all the sides of the buildings and it looks way too much realistic than before. And it might be possible that some of you might be having some doubts here, so let's revise each and everything that we have done in the shader editor till now. See, to get these windows, we first added this Warner texture, made some changes here and ended up in getting some square spots which slightly look like windows. Then we added this color ramp and we used the pointers here to change the position, or basically the thickness of the borders of these windows. For example, if I increase the whiteness with the help of this second pointer, then the buildings would look like this. Similarly, if I increase the blackness, then the buildings would look like this. Then to have different materials like the color and the roughness for the windows and the rest of the building, we added two separate principal BSDF, and to join them we used the mix shader and connected it to the material output. And now suppose you want to change the color of these buildings, so you can simply go to this base color option here and increase the brightness from here and change the color to anything like blue or green, and the color would change here. But suppose you want that these buildings should have some random colors, and for this we'll be using the Musgrave texture, and to add it we first have to press Shift plus A, then go to texture, and you will observe that there's no such texture here. And I told you in the previous chapters that in the recent Blender 4.1 version the Musgrave texture was removed and it was replaced by the noise texture. So we'll add the noise texture and place it over here. Now turn off this normalize, and now we can use this noise texture just like the Musgrave texture. Now since we'll be using this noise texture to give random colors to the windows of the building, I'll take this factor socket and connect it to the principal BSDF which has the black base color using the base color socket, and we see some Musgrave texture here. To give it some colors, let's add a color ramp here. So I'll select this color ramp and let's create its duplicate by pressing Shift plus D and place it here. To change the colors, let's select the first pointer and click here to change the color. Increase the brightness, and suppose I change it to red color, but now all the buildings are turned to red. To add some new colors, click on this plus icon and let's change this color to something like blue, but here you can see that it is not giving the desired result. It is basically applying all these colors to the textures and not to the different buildings. To fix this, we'll be using the object info node. So press Shift plus A, go to input and select the object info, place it here. Now to tell this noise texture that we want the colors to be applied to different buildings, we have to use this location socket here. Let's connect it to the vector, and if I change the scaling from here, you will begin to notice that some random colors are being assigned to different buildings here. Let's even increase the number of colors from here by clicking on the plus icon, and let's change it to green color. Now this little building here is colored green, and let's also try to move these pointers to change the color of the buildings. Let's select this blue one and move it here. Similarly this green one and move it here. Let's also change the color of this white pointer by clicking on it and changing it from here. So let's change it to yellow color. To get the random colors properly, we have to play with the scale value and the position of these pointers here. So let's try to change the scale value and also these pointers in order to get some different results. And let's also try to change the scale value from here. Like if I reduce it, we'll get different results. So you should try to change the scale values and the position of these pointers. Try to add some more colors and you will get different results each time. But I think that right now this combination looks perfect. So let's finalize this. And suppose you want to change the color of the rest of the building. Right now it is set to white color, but suppose you want some other color. So let's go down, and here in the second principal BSDF we have the base color option. So if I change it to black color, you will observe that the borders of the windows, or basically all the part except the windows, is now colored black. And as I told you before, you can change the thickness of these borders or simply these lines with the help of this color ramp. So if I take the second pointer and move it like this, the thickness or the width will basically change. But I think that this much is fine, and you can even change other things like to make them look metallic. You can increase the metallic nature from here or make them look rough from here. So you can try to change these different settings to change the material of the windows or the rest of the building. This principal BSDF will work for the windows, and the second principal BSDF will be used for the remaining building. And here I think that we should change the roughness of the windows to exact 0 in order to make them shiny and reflecting. And now our buildings are completely ready. But if you remember, we added this this grid or the plane and use the instance on points to add these cubes at the position where the points or the vertices of this plane were located. As a result, whenever you want to increase the number of these buildings, you can simply go to the vertices option here, and right now their value is 4, but suppose you want to increase it to a higher number like 8 or 10, then the number of these buildings will increase, but you need to adjust their size from the size option here. So if I increase the size in the x-axis, then these buildings will move apart in the x-axis like this. Similarly, to move them apart in the y-axis, I'll take this size in the y-axis and increase it, and now it looks like this. So you can try to change these values to change the number of buildings in your scene and also the distance between them with the help of the size option in the x and the y axis. And also, if you want to change the random colors that are assigned to these buildings, you can again go to the noise texture and change the scale value from here, or you can also go to the color ramp and change the position of these pointers from here. But I think that we should finalize this one, and this is how the final output looks like. I added a simple plane below its surface, added some lighting, and this is the final rendered output. Also, this brings us to the end of this chapter. Our next chapter will be chapter number 32, Geometry Nodes, Creating Fence. So don't forget to subscribe to our channel, press that notification bell so that you can get timely updates about the upcoming chapters. Thank you for watching, and we'll see you in the next one.